Hello friends, I am Dr. Dafda, and in this video we will see India's fascinating space journey from Chandrayaan to Aditya L-1. The Indian space program began in 1960s with the launch of its first rocket, which was small and basic. But over the years, India developed its capabilities, launching satellites to study space, weather and communication. And see, this space science is not simple. It involves a great deal of complex physics, engineering and mathematics, and very few countries in the world succeeds in this complex astrophysics. For India, it was possible due to hardworking and great scientists like Dr. Vikram Sarabhai sir, often known as the father of the Indian space program, Dr. APJ Abdul Kalam sir, also known as the Missile Man of India, Professor Satish Dhawan sir, UR Rao sir, Nambi Narayan sir, and many more. In 2008, India sent a mission to Moon called Chandrayaan 1, and in 2024, India's Aditya L-1 solar observatory was inserted in its targeted halo orbit in the very first attempt. And the program continues to grow, aiming for more advanced missions, including human spaceflight in near future. So it is a story of steady progress, achieving more with each step. Okay, so let us dive into the details. India launched its first mission to Moon, Chandrayaan 1, on October 22, 2008. The mission's goal was to explore and map Moon's surface. Chandrayaan 1 carried a suite of scientific instruments that studies Moon's geology, mineral composition, and the lunar environment. And one of the most important discoveries made by Chandrayaan 1 was the presence of water ice molecules in the Moon's polar regions, a finding that surprised scientists worldwide. Why? Because it suggested the possibility of life on the Moon in the past or future, and the mission also provided detailed maps of the Moon's surface. Although the mission lasted only for about 10 months, it was a huge success for India. Chandrayaan 1 proved India's ability to conduct complex space missions. The mission inspired future space exploration efforts in the country, and it was a proud moment for India and demonstrated its technological advancements. Chandrayaan 1 laid the foundation for future missions like Chandrayaan 2. Chandrayaan 2 was India's second mission to the Moon. It was launched on July 22, 2019 with an orbiter, a lander and a rover, and the goal was to explore the Moon's south pole, which is a cold and a dark region and had never been explored before. It consisted of an orbiter, a lander named Vikram, and a rover named Pragyan. The orbiter successfully entered lunar orbit, but the lander had a hard landing and was damaged. Despite this setback, the mission is considered a success because the orbiter is still operational, providing important information about the Moon's surface and its environment using scientific instruments like terrain mapping camera, spectrometer, etc. This is a 3D view of a crater on the Moon generated from images captured by Chandrayaan 2 orbiter's terrain mapping camera. Chandrayaan 2 showcased India's advanced space capabilities and commitment to the lunar exploration. Chandrayaan 3 is India's third mission to the Moon, launched on July 14, 2023. Unlike its predecessor, this mission focused solely on landing, consisting of a lander named Vikram and a rover named Pragyan without an orbiter. Chandrayaan 3 aimed to achieve a successful soft landing on the Moon's south pole, an area rich in water ice and scientific interest. On 23rd August 2023, the mission succeeded, making India the first country in the world to land near the Moon's south pole and the fourth to achieve a soft landing on the Moon. The rover explored the lunar surface, sending back valuable data about the composition and characteristics of the Moon's soil. Recently, in August 2024, scientists in India have released the findings of studies carried out by alpha particle X-ray spectrometer on the rover module. The findings comprise the first analysis of the composition of the topsoil in the Moon's southern latitudes and support the widely accepted hypothesis that the lunar surface in the immediate aftermath of the Moon's formation was covered by a sea of molten material. The data collected by alpha particle X-ray spectrometer also contain new information about the elemental composition of the lunar surface that can help to better understand the evolution of the Moon. And this is the actual photograph of the Vikram lander taken by the Pragyan rover. Chandrayaan 3 is a proud achievement for India, demonstrating its growing expertise in space exploration. The Indian Mars Orbiter mission, also known as Mangalyaan, was India's first mission to Mars, launched on November 5, 2013. It aimed to study the Martian surface, atmosphere and mineral composition, and remarkably, India became the first country to reach Mars on its very first attempt. And the mission was completed on a budget that was one of the lowest for a Mars mission. In fact, its budget was only rupees 450 crores, which was even less than the budget of some big Hollywood or Bollywood movie. Mangalyaan entered Mars orbit on September 24, 2014 and sent back stunning images and valuable data about the planet. The mission lasted far beyond its expected life, operating for nearly 8 years. Mangalyaan was a huge success for India, showcasing its growing capabilities in space exploration and earning global recognition. Aditya L-1 mission is India's first space mission dedicated to studying the sun. It was launched on 2nd September 2023. The mission's goal is to observe the outermost layer of the sun called the corona and to understand solar activities like solar flares and their impact on the space weather. Aditya L-1 is positioned at a special point in space called the Lagrange point 1 or L1, and therefore the name is Aditya L1. It is about 1.5 million kilometers from the Earth, where it can continuously observe the sun without any interruptions. The Sun-Earth Lagrange point L1 is a location in space where the gravitational pulls of the sun and the earth balance out, allowing the spacecraft to hover or to stay relatively stable with minimum fuel usage. And this makes L1 a good place for spacecraft to observe the sun and the earth and communicate with the earth. Placing a satellite in the halo orbit around L1 point allows continuous observation of the sun without occultation or eclipse, providing an advantage in monitoring solar activities. Aditya L1 entered its targeted halo orbit around the Sun-Earth Lagrange point L1 recently on 6th January 2024. And see, this mission will help us predict and monitor space weather events which can have significant impacts on satellite operations, communication systems and even the power grids. And this mission will help scientists learn more about how the sun affects our solar system, including the earth. And Aditya L1 is a significant step for India in solar research, demonstrating the country's expanding capabilities in space science. India's future space missions such as Gaganyaan aim to strengthen its position as a major player in space exploration. Gaganyaan is India's first crewed space mission where Indian astronauts will be sent to the space by 2028, marking a historic achievement. Beyond Gaganyaan, India plans to explore Moon, Mars, Venus and even deep space. These missions will not only expand our understanding of the space but also inspire new generations and create advanced technologies that can benefit life on the Earth. And remember, India benefits economically from its space missions by boosting its space industry's global reputation, attracting commercial satellite launches, and fostering international collaborations. See, these missions drive innovation, creating new technologies that can be applied in various sectors like telecommunication, agriculture, and disaster management. Additionally, they also create jobs, stimulate investment in science and technology, and help develop a skilled workforce, contributing to the overall economic growth. Overall, India's space future is bright with plans to push the boundaries of science and technology. So that is all for this video lecture. Thank you very much.